Okay, so what I've done is I've copied this from the previous page, and I didn't talk about it when it was at the circles, and it says our calculators will only find one angle that has the ratio, but in almost all cases there are two, really important, um, there are two angles that have the same ratio. And if I go back up to what we just finished doing here with this table, if you look here, here is positive 0.87. Here also was positive 0.87. Now, if you type the sine inverse of 0.87, and I'm going to do that so that you can see. Now, obviously, it's not going to be exactly 120 because we didn't keep 4 decimal places. But if I do sine inverse of 0.87, my calculator only gives me the 60 degrees. But 120 degrees also has the exact same ratio. So in other words, if I do it backwards, sine of 120, it gives me the same ratio. So it means that I now have to do some work besides the calculator. And now the same is true, for instance, cos. Cos is positive 0.05 here, and it is also positive 0.05 in the fourth quadrant. And my calculator will only give me one of those angles. So this is what we're going to be doing next, is how do I find the values if theta is between 0 and 360? How am I going to find them? Okay, so the very first thing that we're going to do, and it's really not that difficult, it's a little bit different, but not difficult. Okay, so the first thing I'm going to do is I am going to take my calculator and I'm going to find the ratio that has the angle that has this. So my calculator, so theta, and if I do the cos inverse of that cos inverse of 0.1269, let's see what our calculator gives us. So up comes the calculator, and cos inverse of 0.1269. It tells me it's approximately 83 degrees, or 82.7. We'll say 83 to make our life easy. So, and I forgot what I was going to put down. Isn't that awful? So 83. So I'm going to put 83 as our answer. Now, the other thing I need to consider is, where is cos positive? Well, I'm going to bring up the cast rule here, and this tells me where it's positive. So I know that I have to have an angle located here and here. So I know I have a terminal arm here, and actually that's in the first quadrant, and so that would be where my 83 degrees is. Now, I also have in the fourth quadrant another one that is all the way around to here. And this was that right angle triangle of 83. This here also is a right angle triangle, and it also is going to be 83 degrees. So the way I get this second theta, okay, so this is our first theta. Our second theta will be 360, take away the 83. And so when we do that, so we end up with 277, which is in the fourth quadrant, which is true. Okay, now let's look at the next one. I know that the next one is a negative one, but I'm not going to care one way or the other if it's positive or negative to begin with. I'm just going to get my calculator to tell me what right angle triangle has 0.5 as its ratio. And when I do that, we'll bring up our calculator. And of course it went to sleep, just like the real ones. Oops. we end up with 30 degrees. So I know that the 30-degree triangle, those little right triangles that happen everywhere, equals 30 degrees. Now, because sine is negative, this ratio is negative here, I know that according to CAST, sine is positive here and here. So that means it's located in the third and fourth quadrant. So when it is in the third quadrant, this is the 30 degrees here, but the theta I'm talking about that I want for this question is all the way around. So it's going to be 180 plus the 30. So I have a theta 1, which is 180 plus 30. So we have 210. And that would be in the third quadrant. I also have, according to this, sine is also negative down here. So it means that this right angle triangle here is 30. So when I go around, I know that this is the second theta that I want. So my second theta is going to be 360 minus the 30 to give me 330 degrees. Now, what you can do is you can actually take your calculator and work backwards as well. So we think that we've got it right. So let's try. If I take the sine of 210, I should get negative 0.5. So let's try that. So the sine of 210, yes, it does equal that. So we know that one is correct. So we could check it. Now we don't want to guess and check everywhere, but this is just checking. So now if I take the sine of 330, we better get negative, and we do. So we know that we've done it correctly. So let's do one more, and this time we're going to do tan. Again, I'm not concerned right now whether it's positive or negative, and we can see that it is positive. But let's first of all do theta, because we want to find out what that right angle triangle equals in all four quadrants of 2.3568. And up comes the calculator again. And if we go tan inverse of 2.3568, we end up with 67 degrees. So we know that all the way around, if I go, this time I'm going to draw all four. You don't have to draw all four, just to explain. I know that there is a triangle, a right triangle, in each one of these that has the number, I don't care if it's positive or negative, 2.3568. Now, I'm only interested in, for this question, the place where tan is positive. Now, according to CAST, remember CAST told me that tan is positive where the A is and where the T is. So when I look here, the right angle triangle, so I'm looking at this one and this one. Okay, so my calculator gave me this one because it's 68 degrees, which is less than 90. So my first theta is going to be 67 degrees, and my second theta, which is located in the third quadrant, which is this one, is going to be 180 plus the 67. So we end up with 247 degrees. Okay, so hopefully this was easy enough for you to follow. It is a very different concept. I'm not going to say it's hard, it's just something that you've never seen before.